about the process scheduling, particularly in FCFS technique. We are going to calculate the average turnaround time and average waiting time of all processes which are given to solve. First of all, question will ask like this: solve the following example using FCFS technique, and examiner or in question paper this type of question is assigned for you. In that particular type of question, there are process names, arrival time of processes, and burst time of processes. First of all, we have to learn about the processes. There are several processes given in example: P1, P0, P3, P4, like this. Any other name can be assigned to processes. First of all, while going to solve, this is the arrival time. In the arrival time, it indicates at which time process comes in ready state for its execution, and burst time indicates, burst time gives the time to complete the process. Means the process P0 requires 3 milliseconds to execute it completely. Like this, we have to solve the given example by using the Gantt chart. First of all, we are going to draw the Gantt chart. In this Gantt chart, we are going to show all the processes which are comes in ready state, and according to that arrival time, we will assign the processes, or we will keep the processes sequentially. First of all, Gantt chart always starts from 0. Gantt chart always starts from 0. Then at the 0 millisecond, process P2 comes in picture. That means when the CPU starts, when operating system starts working, at that time process P2 comes in picture. That is why process P2 will be the first executing process in given example. Means we will assign CPU, we will assign processor to P2 process. Means P2 will start its execution from 0, and P2's burst time is 3 milliseconds. Means the execution of P2 will start from 0 and ends on 3. At which time process starts its execution, it's called as starting time of process, and at the time where process finish its execution, it's called as finish time of process. Means in this Gantt chart, 0 is the starting time of process P2 and 3 is the finish time or end time of process P2. Obviously, when CPU goes up to 3 milliseconds, at that time we will see which process comes in picture for its execution. We can see that the second process which comes at 1 millisecond, name is P0. Means whenever process P2 is executing by CPU, by operating system, at that time, same time, process P2 is arrived. Means when process P2 is executing, process P0 is in waiting state. After completion of process P2, process P0 will execute. Process P0 will execute. Means starting time of process P0 will be 3 milliseconds, because all the resources and input output devices makes free at 3 milliseconds by operating system. This process P2 will start its execution from 3 milliseconds, and it is having burst time of 3 milliseconds. Means we have to add 3 more milliseconds into this finish time of process P0. This 3 plus 3 will go up to 6 milliseconds, and when CPU goes up to 6 milliseconds, process P2 will complete its execution. Process P0 will complete at 6 milliseconds. At that time, there are several processes comes in picture for its execution. Means all these processes are in ready state. This process P2 and process P0, two processes are completed by operating system. The remaining two processes P1, which comes at 2 milliseconds, and it is having burst time of 4 milliseconds. Here process P1 will execute because P1 is arrived earlier than process P3. Means process P1 will start its execution from 6 milliseconds, which are executing with the help of CPU or executing with the help of operating system. So process P1 is having burst time of 4 milliseconds. That means we have to add 6 plus 4 more milliseconds in that previous finish time, and process CPU goes up to 10 milliseconds. At this time, at the time of 10 milliseconds, process P1 will execute it completely. After that 10 milliseconds, the last process which have already arrived at 4 milliseconds, because its arrival time is 4 milliseconds, it is having burst time of 2 milliseconds. Means we have to add 2 more milliseconds in the previous finish time of process P1. P1 is having finish time of 10 plus 2, which is the burst time of process P3, and the CPU will end on 12 milliseconds to complete execution of given 4 processes. This is the Gantt chart. This is the pictorial representation of ready queue. Means process will be executed in that sequence P2, P0, P1, and then lastly P3. And processes are also coming in that sequence. Then we are going to calculate the waiting time of each processes. Waiting time is nothing but the time for which process kept in waiting state and ready, and process will wait for its turn. Means here is the formula: waiting time equal to starting time minus arrival time, and hence we are going to keep the values of starting time and arrival time in the formula. Means waiting time of process P0 is nothing but the starting time. Starting time of P0 from the chart, we can see the starting time of process P0 is 3 and minus arrival time of process P0 is 1. Means we just have to minimize 3 minus 1. The answer is 2 milliseconds. Millisecond is the unit for each process, each time of processes which are executing from operating systems. In secondly, like this, similarly, we are giving the examples. Waiting time of process P1 is 4 milliseconds. Waiting time of process P2 is 0 milliseconds, because as soon as process comes in picture, P2 comes in picture at 0 millisecond. At that time, it is executed by CPU. That means there is no waiting period or waiting time for process P2. That is why it is having waiting time of 0 milliseconds. Similarly, P3 is having 6 milliseconds waiting time. Finally, we are going to calculate the average waiting time, and we know the formula of average: addition of all waiting times divided by total number of processes. That means when we add all waiting time of processes, that is 4 plus 0 plus 6 plus 2, addition is 12, and total number of processes are 4. Means average